right, everyone. Today we're going to be reviewing the binomial theorem. This is actually something that we've done before. We did this in the first semester. So what the binomial theorem does is it allows us to take a binomial and to basically expand it. So normally we'd have to write this, if it's to the fourth power, 4 times and then distribute. That can be kind of problematic, but we can use this binomial theorem to help us with the binomial expansion of any binomial a plus b to the nth power. So let's just review what our steps are. The first thing we're going to do is our step 1 was to write the coefficients of each term using the nth row of Pascal's triangle. We'll review that in a sec. Now, step 2 is from left to right. We're going to include the first term of the binomial with each term of the expansion using the exponents in decreasing order. Then step 3, I want you guys to change this to left to right again, okay? Because that's how we did it last semester. So then from left to right, we'll look at the second term of the binomial with each term of the expansion. And this time we can use the exponents in increasing order. And then step 4 is where we simplify the results of the products. And then we're going to add if the binomial is a sum. And then we alternate the sign if it is a difference. The first term is positive, the next term is negative, etc. So that's what's important, is the first term is positive. So let's review and draw Pascal's triangle through row 6. We know that we start with row 0, which is just the number 1. Row 1 has 1, 1. Row 2 has 1, 2, 1. And we've discussed how the outside edges of Pascal's triangle are always 1s, and then we can add these corresponding pieces to create the inside terms of the triangle. So then we have 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and then 1, 6, 15, 20, 15, 6, and 1, okay? Remember that this is row 0, okay? And that then we have row 1, row 2, row 3, etc. The row number should have that number in it somewhere, okay? So you guys, this asks us to write the binomial theorem, to write the binomial expansion of this 4x cubed minus y squared to the 4th power. So because this is to the 4th power, that means we're going to use the 4th row of Pascal's triangle. The 4th row has the number 4 in it and has 1, 2, 3, 4, 5 terms. So we said that we're going to take 1, 2, 3, oops, sorry, 1, 2, 3, 4, 5 terms that we'll use. Okay, so the 4th power means that we're going to use the 4th row of Pascal's triangle. All right, so using, which has 5 terms, so we wrote those out, and now we're going to write all those coefficients. 1, 4, 6, 4, 1. Alrighty. Now we go to step 2. Step 2, we have the first term, which is considered 4x cubed. We're going to take 4x cubed, put it in parentheses, please, and we're going to write the exponents in decreasing order. So that means since we have 4 as the exponent, we're going to have it to the 4th power. Next, we're going to have 4x cubed to the 3rd power. Next, we're going to have 4x cubed to the second power, 4x cubed to the first power, 4x cubed to the 0 power. You guys remember doing that? Step 3. Now we're going to take the next term, which is y squared. Just ignore the sign at this point, okay? So then we're going to take y squared, put it in parentheses, please, and we're going to use them in increasing order, and we're going to start with 0. So y squared to the 0, y squared to the first, y squared to the second, y squared to the third, y squared to the fourth, okay? And you should be able then to have, notice that one exponent decreases 4, 3, 2, 1, 0. These increase 0, 1, 2, 3, 4, okay? Now, we're going to simplify each of these. And if you remember, I wrote the parentheses. I'll have each term still here. We're going to simplify each piece in the parentheses. So the 1 stays 1, but the 4x cubed to the fourth, that 4 needs to be applied to both the 4 and the x cubed. So 4 to the fourth is 256. X cubed to the fourth, remember you multiply exponents, so that gives me x to the 12th. Now I do y squared to the 0, that's just 1. Let's do the same thing with these other terms. Let me bring down this 4. 4x cubed cubed, I need to cube the 4 and cubed the x cubed. So 4 cubed is 64. X cubed cubed is x to the 9th. Y squared to the first is just y squared. And notice these are just multiplication symbols. Moving on, I bring the 6 down. I'm going to square the 4 and square x cubed. So 4 squared is 16. X cubed squared is x to the 6th. Next, y squared squared. That would be y to the 4th. Bring the 4 down. Everything to the first power is just the first power. So that's going to be 4x cubed. Y squared cubed. I'll multiply these exponents to make y to the 6th. And then anything to the 0 power is just 1. And y squared to the 4th is y to the 8th. I kept the 5 slots to make sure that you only have 5 terms, because we now need to clean this up. Let's multiply all the numbers. 1 times 256 times 1 is 256. And as far as variables, I have x to the 12th. Let's multiply numbers here. 4 times 64. That also is 256. And then let's look at the variables. X to the 9th, y squared. Let's multiply here. 6 times 16 is 96. And then variables, x to the 6th, y to the 4th. Notice in my final answer, I'm not writing the multiplication symbols anymore. Here, 4 times 4 is 16, x to the 3rd, y to the 6th. And then here I have y to the 8th. So notice I still have 5 terms. Now what's missing? What's missing are the signs. And remember that because we have a difference, we're going to alternate the sign. The first term is positive. What is our first term? You guys, this is our first term, okay? The 256x to the 12th is the first term. So that means that we'll alternate signs from there. Minus, plus, minus, plus. And we usually don't care about a positive sign, so I'll just not happy cloud that. But my final answer would be 256x to the 12th minus 256x to the 9th y squared plus 96x to the 6th y to the 4th minus 16x cubed y to the 6th plus y to the 8th. Okay? All right. So here is a you try question, and because it's a video, I guess we'll do it together because I doubt you're gonna do the you try piece. So we're in the you try question, we're going to use 5x plus 2y to the third power, but I'll go kind of quickly through this since we've done it before. So because it's to the third power, we're going to use the third row of Pascal's triangle. The third row of Pascal's triangle has 1, 2, 3, 4 different terms. Okay. I look at row 3. 1, 3, 3, 1. So those are the values that I'll put here. I then take the first term, which is 5x, and I start with the third power, and then I work my way down. 3, 2, 1, 0. I then take my next term, which is 2y, and I start at 0, and then I work my way up. 0, 1, 2, 3. That's the setup part. This next part, some kids skip this step, and it just breaks my little heart because it's so important to have this piece. This is usually the step that people mess up on when they try to jump this step. And this is where I'm going to simplify each of the pieces. So this is 1. 5x cubed, we need to apply that cube to both the 5 and the x, so that's 125x cubed. And then 2y to the 0, anything to the 0 is just 1. Next I have 3 times, again I need to apply that to both of those. So 5 squared is 25, x squared is x squared. 2y to the first, we know anything to the first is just itself, so times 2y. Here I have 3, and then 5x to the first is just 5x. Oh, but here's an exponent that'll apply to each of those, so times 4y squared. And then I bring down the 1. 5x to the 0 is 1. 2y cubed is 2 cubed, which is 8, and then y cubed. So I multiply all the numbers together. 1 times 125 times 1 is 125, and then variables, I have x cubed. You guys, all of these numbers get multiplied. I had some people before that were trying to like add and subtract. Be careful about that. So 3 times 25 is 75, times 2 is 150. So multiply all the numbers together, and then we have x squared y. And some people are like, well, they're not like terms. You guys, these aren't terms. These are factors. We can multiply all of them together. And then 3 times 5 is 15, times 4 is 60. And then variables, we have xy squared. 1 times 1 is 1 times 8 is 8. And then variables, we have y cubed. So now I need signs. Again, make sure that you only have 1, 2, 3, 4 terms, just like we started with. And I noticed that this is a positive. So the nice thing is that all the values are going to be positive. So I just put plus signs between. And that's a little review of binomial expansion. And we talk about that a little bit because of the relationship between Pascal's triangle and the combinations that we looked at, okay? So the other thing we're going to look at today is how can we use combinations to find out how often certain hands of cards appear. If you need to get out the deck of cards that we spoke about, you can do that, but that's kind of how we're getting these numbers. So this question says, find the number of possible 5-card hands that contain the cards specified. The cards are taken from a standard 52-card deck. So notice here we have 4 queens and 1 other card. So remember, we know that this and means that we're going to multiply those things together. And so we said that when there are these subgroups, we only consider the subgroups. So when it says 4 queens, what that means is that we're going to just think about how many queens there are total. How many queens are there total in the deck of cards? Well, there are 4. And how many do we want? Well, this says that we want 4 queens. And when we have a hand of cards, you guys, a hand of cards is a group. And because it's a group, that means that we're going to use a combination. So the 4 queens are going to be 4C4. Now notice then it talks about other cards. When it talks about other cards, it means cards other than a queen. Well, remember that there were 52 cards total, and we're talking about cards other than queens. So other than queens would be 52 minus 4, which is 48. So as far as other cards, there are 48 cards to choose from. And this is saying that we're going to have one of those. And so then we could just type that in. We could type in 4C4 times 48C1. And in case you don't have your calculators out, I'll tell you that that ends up giving us 48. Okay. So let's look at this. Next one says 1 queen and 4 cards that are not queens. So the and tells us we'll be multiplying those together. And this time we start with 1 queen. So how many total queens are there? Well, we said in a deck of cards there are 4 queens. And we want only 1. So 4C1. Now this is 4 cards that are not queens. Again, one other card, right? So that means, again, the cards that are not queens would be 52 minus 4, which is 48. So we have 48 cards total. And so that is, we're going to then be picking 4 of those. So then we would take 4C1 times 48C4. And I'll tell you that gives us 778,320. Okay? Next, at most 1 ace. Here's where you're going to have to trust me, guys. When you see something like at most 1 means that you can have either 1 ace leave a little space, or 0 aces, right? If you have 1 ace in a 5-card hand, that means that at the same time as having 1 ace, you also need to have 4 other cards. So this is what we're going to look at. This 1 ace really implies that you need 1 ace and 4 other cards. And that means that if we have 0 aces, that means that we need 5 other cards. And again, this is not something I would necessarily think of off the top of my head. That's why I'm kind of talking you through it. So we know at most 1 means 1 or 0, but we also have to look at the other cards as possibilities. So let's look at that 1 ace and 4 other cards. How many aces do we have? 4, and we want 1. So that's 4C1. And means that we'll multiply 4 other cards. Well, if there are 4 aces, that means there are 48 other cards. And we're going to pick 4 of those. Or means that we would add. 0 aces Well, that means that we would have 4 aces, but we want 0 of them. And other cards, that means there are 48 other cards, and we want 5 of those. And so we would enter that together. We would just put that in our calculator, if you guys trust me on that. And as our answer, we end up getting 2,490,624. Okay, that would be our answer there. Okay, so let's try that with this idea, at least one club. So at least one club means that you could have 1 club or 0 clubs. But if you have 1 club, that means that you need 4 other cards in your hand. Basically 4 non-clubs, okay? And then if you have 0 clubs, that means that you need 5 other cards in your hand. Other cards meaning non-clubs. So let's look at this idea of 1 club and 4 other clubs. So how many clubs did we say they were? A club is a suit, and there are 13 cards in a suit. So there are 13, and we want 1 club. So that means we want 4 cards that are not clubs. So if we took 52 minus 13, that gives me 39. So that means we have 39 other cards that are not clubs. We want 4 of them. And means we multiply. Remember, or means that we would then add. And then 0 clubs, again, we have 13 clubs. We want 0 of them. And then other than clubs, we said over here we have 39, and we want 5 of those. And if you put this in the calculator, it'll follow order of operations. It'll find this and then add this if you enter it in correctly, or if you enter it in correctly. And when I entered that in, I got 1,645,021 possibilities. Okay? I'm more interested in the setup than you guys punching things in at this second. Okay. The last thing we're going to look at is this idea of at least 3 hearts. Okay? So if you have at least 3 hearts in a 5-card hand, that means that you could have 3 hearts, leave a space, or 4 hearts, or 5 hearts, right? At least 3 means 3 or 4 or 5. But remember, if you have 3 hearts, what does that mean? If you have 5 cards, 3 of them are hearts, 2 of them have to be something else. So then we have or 4 hearts. So 4 hearts means that you have to have 1 other card. If you have 5 cards, do you need any other cards? You don't. You could put and 0 other if you wanted, but again, if we have our full 5 hearts, then our hand is full, we're good. So let's look at each of these. Let's look at 3 hearts and 2 other. So how many hearts did we say there were? We said that there were 13 hearts, and we would want 3 of them. And if there are 13 hearts, then we said that 52 minus 13 is 39 non-hearts, and we would want 2 of those. And remember, and means that we would multiply. Now we can look at the other possibility of having 4 hearts and then 1 other card. So again, there are 13 hearts. We want to pick 4 of them. And then if there are 13 hearts, remember there are 39 cards other than hearts, and we'll pick 1 of those. And then finally we have the 5 hearts. That means there are 13 hearts, and we want 5 of them. or means that we would add those components together. And if you add all those pieces together, I got 241,098. I hope I typed that in correctly. Okay? So this is a really nice practice with getting with the cards and practicing everything we looked at the other day with the combinations, the idea of the ands versus the or. So hopefully you guys will have luck with that tonight. So this is very similar to one of the questions on your worksheet, okay? All right, hopefully you enjoy the rest of the time and get a head start on the assignment. Have a good day.